Okay, welcome to the class. Last time we stopped on this slide. We were discussing plotting, and hopefully in this lecture we will conclude the basics of what we need about plotting. And so let's get started with this. So remember last time we did this, we used the mesh grid command or function, and the mesh and surf functions to generate this plots that we see here, right? The mesh function again just looks like a mesh, like a chain fence, if you will, showing you the different cells. And then if we use the surf command or function, it just fills in the different cells with colors. But you still get a three-dimensional plot or view of your function. One key aspect of using three-dimensional plots is to use the mesh grid command that we've been talking about earlier. And I want to just do a couple more minutes on that to kind of make sure you understand what we need that. And if you look at, for instance, this function on the left, okay, there's a single free variable, right, which is x, and is represented by a single axis on a two-dimensional plot. And if we plot a function with two variables, in this case, if we're plotting, or if you want to plot x1 squared plus x2 squared, then we have two variables. And the two free variables must be represented as two axes on a three-dimensional plot. So if we look at it from above, then it looks something like this, where we have to define x1 and x2. And so there's another variable that doesn't show up in this plane because we have another variable that is shooting up mostly on the third dimension condition. So for the program to understand where is it going to put all the different points along the plot, it needs to define the function on the whole plane. You need to define the grid on the points of the plane, so that by defining the individual grids, so you can find the points here for each of the grids, then the function knows where to go and create that three-dimensional plot. So the grid is a collection of coordinate pairs arranged in a two-dimensional fashion. And you can create, for instance, a variable x1g and x2g using the mesh grid command, and then use it to create the plot. And we did this before. We created the x and y, and we provided those arrays to the mesh grid command, which then created the grid that you see on this plot here, right? We did this here, right? We use the mesh grid command, and basically what that does is create that point of reference for the figure or for the command to know where it's going to put all the different plots. And so, for example, going back here, we can summarize what you need when you use this three-dimensional plots, is to first define the free variables, right? Like in this case, we have x1, 0, and x2, x1 going from 0 to 4 and x2 from 0 to 5. And the second thing is to create the grid. So that's where the mesh grid command comes in. And then using the mesh grid output, we're going to use those variables to define the grid that the function uses. And finally, you just plot it. And that's basically what we did before, if you remember, right? We had the variables, then we used the mesh grid command that the actual function can use to understand where is it going to put all the individual points along the curves. So so that's the need of the mesh grid command, right? So it creates that sort of guide for the different points in terms of a mesh, in terms of grids. Okay. All right. So let's move on now to another feature of plotting, which is the contour plots. And the contour plots are two-dimensional representations of a three-dimensional surface, right? This is what you will see if you, like a bird's eye view of a three-dimensional plot. It creates a matrices X and Y that define a grid in the XY plane. And we define the matrix Z as the heights above that grid, then the contours are plotted for that Z variable. So for example, here, we have defined a set of numbers using the lin space for X and Y for X from 2 pi to from minus 2 pi, I'm sorry, to 2 pi, and for Y from 0 to 4 pi. Now remember, we haven't specified here the number of elements that we want here, right? That will be the third element. If we wanted to have a specific number of numbers generated between the two endpoints. But by default, if we not specify that number, then by default, the function lin space is going to give you 100 equally spaced elements. Okay, so if we don't define here as the third argument the number of equally spaced elements that we want, then MATLAB by default is going to give you 100. Okay, but anyhow, that's what we have here. We have X going from minus 2 pi to pi, and Y going from 0 to 4 pi. So we define X and Y, and then we use the mesh grid to, excuse me, to help MATLAB understand where the points are going to go. And then using these matrices X and Y, then the function will understand where to put all those points, because it understands that it's going to be using a third-dimensional view, if you will, because he has to understand, even though you're looking at a two-dimensional plot, he has to understand, the different areas that has to cover based on that grid. So in any case, the contour function creates a contour of view, if you will, of a three-dimensional plot. And if we look at this function, which is the same function that you see that we see here, the same function here that we see plotted, right? Which is plotted again here. But so you can understand what this means, I also created a couple of other views for the same plot, for the same function rather, sine X plus cosine Y, but from using the surf function, right? And so you can see now how the contour is really, the bird's eye view of this plot, showing you the different areas, okay? Now the contour is a little more defined. It doesn't put any color, around those areas like the surf does in these two cases. And it's just another view of the same plot, right? But it's interesting because you can use it to understand different types of information, right? Like information you can see here, it may not be as obvious when you look at the three-dimensional plot like that, right? Okay. Another example here. Again, and by the way, we use in a subplot command to generate 4 different plots, and we define the values for X and Y. Again, we use the mesh grid to generate the matrices needed to plot the function Z, and this shows us again the different options that we have, different views. And the first one, again, this one we use simply the mesh function to plot this Z function, right? With the with the different parameters given, like the title, the axis titles, and so forth. Then on the second one, we use the surf command for the same function, of course. And the third one, we use the contour, and you can see again, right? It gives you a good idea of how the function is behaving as it moves, for example, for its center, right? And then on the last one, we have another option, right? That shows us, the specifics of how the surface plot really maps on this two-dimensional plane, right? Which, as you can see, is really really interesting, right? Okay. The other thing I want to talk about is, and this is something we've done before earlier when we were looking at the plot for the instantaneous power example that we've been using in several of the lectures. And we generated plots, and we then, within the plot itself, we customize some of the things we wanted to see, right? But we didn't really do it formally, right? I just want to make sure we understand where you need to go if you need to customize a figure or a plot once you created it, okay? Show an example, we use this sphere command, which is one of several sample functions, like the peaks function, that is used really for the purpose of, among other things, demonstrating really how plotting works in MATLAB, how powerful plotting is in MATLAB. So recall that you can force a plot to space the data equally, right? On all the axes if you use this axis equal command. And that's what we've done here. We spaced the axis the same by using the axis equal command. And the sphere function simply does is to create a sphere with a default radius of 1. Okay. The other ways to change the default radius, and we'll get into that probably later, but that's not the main interest here. It's just mainly to generate a plot and to show you how to customize some of the information that you're going to see in it. But in any case, this generates a nice sphere plot with a radius of default of 1, by just simply typing that function name. And of course, axis equal will make the axes equal. So now, in the figure itself, once it's generated, we can use different ways of customizing what we see. So, for example, if you look into the insert part of the menu, if you select that, you can insert labels, titles, insert a color bar if you want. You can insert text boxes and so on, right? Again, something that we did in the previous lecture where we did it from the plot itself, right? But this is useful. Let's say you forgot and you had a long piece of code and at the end you created a figure and then you forgot to add something to it that you wanted to have. So this is a nice way to do it, right? We also have the tools menu, and the tools menu allows you to change the way the plot looks. You can zoom in and out. You can pan. You can rotate the figure if it's a three-dimensional figure, which again is also very interesting because you can generate a plot. Let's say it's a three-dimensional plot like this one, and then by rotating it, you can create many more plots or many more figures of the same plot from looking at it from different points of view. Once the plot is created, you don't need to rerun the program or recreate the figure again by doing things like that. So you can change the aspect ratio and all kinds of things. So these are the things you can do, and I urge you to really just experiment with it and see all the things that you're able to do. Okay. One more thing is if we look at the figure, if you select or go in the figure toolbar, which is right here, you have icons that allow you to do the same thing that that you can do with the, or most of the same things you can do with the menu tools here. And if you remember, we did this a few lectures ago, where we selected the features that we wanted based on this figure toolbar. You also have the edit menu here if you want to change, for instance, things like the figure properties or the axis properties, things like that. This will allow you to make those changes on the spot to the figure you had already created, and then you can save it. The normal, file name for that figure, the extension rather, is going to be FIG. So you can save those figures. If you go under File, you'll see you can save that. Okay. All right. Also, there's another feature which is very useful in MATLAB for creating plots from the workspace window. And again, there's just more ways of generating plots, not necessarily just from writing commands or writing scripts or anything like that. This, again, allows you, by using features like this, you can create image or plots interactively by just using the variables that you have available in your workspace area. So if you select the variables you want to plot, then just select plots from the top, the plots tab from the MATLAB desktop. So here, if you select the plots tab, you'll see the different features or the different figures you can generate, right? And to generate a figure, a plot, of course, you're not going to have, there's another way you can generate a plot instead of using commands. For instance, you can generate a plot. If I select, I'm going to select the variable y here, see? And then I'm going to select plot, and then it automatically is going to plot it. Now, this is a quick way for you to get information based on plots. And then if you want, you can then take this information, this plot, and customize it, like we mentioned in the previous couple of slides, right? So here I selected the variable y and then just use the plot command to generate the plot directly. And actually what's going on, if you notice at the bottom here in the command line, I didn't plot that, but by me selecting plot, the program automatically understands that I'm plotting this variable y. Again, same thing, same variable, but this time I selected the semi-log y, I'm sorry, right? And of course, it's going to plot the semi-log version of this variable. And again, notice here that the program itself runs this command. I didn't do it. The program does for me. But it's essentially the same thing. It's just a quick way of maybe looking at behavior of the variables that you have, and you can look at them as plots. And remember, you may say the figures as by going to Save As and saving it as a whatever plot name you have or figure name you have with the extension FIG. So the MATLAB recognizes it as a figure. All right, so that pretty much does it on plotting. I think we pretty much cover a lot of what we need to come up with nice plots and to customize plots and to make them look nice and to help us understand functions. And so we may come up later with a few other things in plotting that we didn't go into, but the main areas we have covered at this point. So what I want to do now is I want to move on to the topic of user-defined functions. Okay. So when you talk about user-defined functions, if you've done any kind of programming language already, it doesn't matter which one, um, you remember that if you created any functions, the concept behind a function in just about any programming language is basically the same. Okay, they work basically the same way in all programming languages. It's just the formatting may be different, obviously, because of the language itself, but the end result of creating functions and the end result of use and user-defined functions is the same. It doesn't matter what language you use. So if you've used a programming language before, this shouldn't be any new um, material, but it should be still understandable within the context of using it in MATLAB, because MATLAB maybe uses a different format. So anyhow, a function is just a piece of a computer code that takes an input argument from the user and provides an output to the program, or not even from the user, but maybe even from another function or from another piece of code, right? And what a function does is it allows programs to run more efficiently. It enable us to avoid rewriting the computer code anytime we need it, right? So instead of writing a bunch of commands, we can simply write a function that does all the commands for us. And we really did a couple of user-defined functions previously when we looked at the inline and the anonymous function. Those are, you can create user-defined functions with those two ways. Um, so, and for example, obviously we have built-in functions, like we have seen many of them, and just about any computer program will have a built-in function like the sign function, for instance. In MATLAB, the sign function is we use SIN as the name to call up a series of commands that do the needed calculations, right? So behind us calling that function, that SIN, then there's a bunch of code that runs behind it that gives us the results we want. All you need to give the function is an angle, right? And MATLAB then gives you the answer. So it's not necessary for you to know how MATLAB calculates the value of a sine of x, right? You know that it's going to give you that value because that function has already been defined. Well, it's the same concept. You're going to use user-defined functions to create the same effect, calling something that will give you something back that you're interested in getting in as many steps as possible. Okay? So again, MATLAB functions and built-in MATLAB function and user-defined MATLAB functions have the same structure in MATLAB. Each one will have a name, a user-provided input, and some output, right? Some computer output at the end. So clearly from here, if you look at the cosine x function in MATLAB, then obviously the name is COS. You provide input, and the input is in parentheses. In this case, you provide something that is going to be put into this variable x, and then MATLAB or the function, as it is defined, will calculate a result, right, and output that result. So you as a user don't see the calculations that are being done behind that cosine function, but you take the answer. And user-defined functions work the same way. Whatever happens in the function is going to be transparent to whoever is using it, right? The concept is the same. So user-defined functions in MATLAB are created in using mfiles extensions. or the um, which is very common, just like the scripts. Each must start with a function definition line that must include the following: the word function, a variable that defines the function output, a function name, and a variable used for the input argument. So for example, here you have the word function, right? Stating function automatically just MATLAB that you are going to define a function. This will be the function name in this case, my function, my underscore function is the function name. And in this specific case, the function requires one input argument that we call x and calculates one output argument that we're going to call output. Okay, so it takes an input, does something with it behind the scenes, and returns an output. Okay. By the way, the function names like this one here are really arbitrary, as well as the names of the variables. And those are selected by you, obviously it's got to make sense to you how you're going to use it to name the function. And if somebody else is using your functions, it's got to make sense to the user also, right? So it's always a good idea to think about how you're going to name your function, because it's got to make sense. If you write a piece of code and need to either change it or redefine, especially if it's a function and you need to redefine that function or change something in the function a year later, right? It makes more sense to you to have a name that the function can tell you more or less what the function is going to do, right? So in this case, my underscore function is not a good choice, but it's just to show you the concept of where the name of the function goes, right? But what I want you to understand is that whenever you do create your own functions, give it a little thought about the names you're going to give it, because it makes it a lot easier to either debug it later or fix it or improve it or do things with it. All right. So a few things: before a function can be used, you have to save it into the current folder you're using. Just like if you remember, we run some scripts, it's the same thing. You have to save the script, you have to save the function in the folder you're using. The file name must be the same as the function name so the MATLAB can find it. So when you save it, you cannot give it a different name to the file you're saving. It has to be the same name as the function you're defining. Okay. All of the MATLAB naming conventions we learned so far apply to user-defined functions, which is the function must start with a letter. It can only consist of letters, numbers, and the underscore. No spaces and stuff like that, right? You cannot use reserved space or reserved names, like COS or SIN, things like that, which have already been used by MATLAB itself. Any length is allowed in the function name, but again, think about how you're going to use it, and long names are not always a good idea from a programming point of view. The parentheses are needed even if the function has no input parameters. Okay, so like in this case, if the function happens not to use any input parameters, and we're going to look at some examples of that, where that is the case. It happens more often than you think. But if the function doesn't need any input parameters to do what it needs to do, you still need the parentheses. So the parentheses will just be, inside the parentheses will just be blank. And we'll see examples of that in a minute. Okay. Also, once the function has been saved, it's available for use from the command window, or even from a script, or even from another function. Once you save it, another function can use it. You can call it from a script, and you can use it from the command line. So you cannot execute a function directly from the file itself. That's another thing, right? So you can't, you can define a function, write what the function does, and then call it within that same file. It won't allow you to do that. You get an error. So we're going to look at an example next. But one thing to remember is that the more organized you are, the easier it's going to be for you to test your function, to change your functions later, to update them, and to debug it. Okay, so I know sometimes you just want to write a function and get it over with. But remember, it's always a good idea to be organized, because you never know when you're going to need to change something in the function. It may be a year later, and by that time you have forgotten. And if you're not organized, then it's going to be tough for you to try to make changes to it. So whenever you start writing a function, is always in any kind of scripting or programming, it's always a good idea to follow these basic steps. So always follow the steps I suggest you do. Okay, state the problem, list and describe the input and output, develop a hand example if possible, then develop a MATLAB solution, right? So you have a hand example, and then you apply that with MATLAB commands, and then test your solution. And finally, if the solution doesn't work, then you debug it, you fix it and test it again until it does what you think it's supposed to do. And always make sure you use comments, okay? Even inside the function itself, make sure you use comments that make sense to the function you're writing. Okay. All right. So let's look at one example here. We're gonna create a couple of user-defined functions, and we're gonna state the problem first. The problem is to create and test two functions. They're called dr and rd, to change degrees to radians and radians to degrees, respectively. Obviously, we have built-in functions in MATLAB that can do this easily, right? But this is just to show you, if we didn't have something like that, how you can do it rather quickly. Another thing also, remember, is that you want to choose names for a function that are meaningful to you or to the user who's going to be applying this. So in this case, maybe dr and rd are not the best names to define these functions, but they're short, and they help in the example to keep it short at the same time. But that doesn't mean that you don't need to pay attention to the names when you create the functions. Like I said before, make it meaningful, okay? In this case, I guess immediately you can say, well, degree to radians and radians to degrees, right? But if I look at this a year from today, I may not remember what dr means or rd means, right? If I want to use a function. In any case, just keep that in mind. So anyhow, that's what we need to do, right? That's what we need to create. That's the problem. The problem is stated to create those two functions. And then, so the next thing is to describe the inputs and the outputs that we're going to have. So inputs, as a vector of degree values, right, that we're going to have, or a vector of radian values that we're going to have. And then as an output, we're going to have a table that's converted the degrees to radians or radians to degrees, right? That's what we want as the output. So we want to develop a hand example when possible. In this case, it's easy because we know the relationship between degrees and radians, right? Given by these expressions. So you can manually check, in this case, very easily, that the equations are actually correct, right? By just checking a couple of numbers, degrees, if it gives you the right radians, and the radians if it gives you the right degrees. Meaning that whenever you're going to put into your function, is actually valid, right? Garbage in, garbage out, right? If you put in the function something that doesn't work in the real practical purposes of the function, then you're not going to get a good result. So whenever possible, check that whatever you're trying to implement actually works by doing hand examples whenever possible. So that's step number 3. Step number 4 is we finally develop the MATLAB solution. And the MATLAB solution is then just simply says, well, let's use the function name to define the function that we want. And the way you do it in MATLAB is if you go into the editor tab, the editor tab is going to be one of those tabs available in MATLAB. Let's see if we can go to one right here. So you can see it right here. It's next to the apps, right? So to start writing script or a function, you go to the editor to the editor tab, and then you can start writing your function. Now, you don't really need to use only the editor in MATLAB. In fact, you can write your functions, saving them as a text file. As long as you have the M extension, then you can import it into MATLAB, and MATLAB will understand. The only thing that you have to be aware of is that the advantage of using the editor in MATLAB is that MATLAB will correct you a lot of times. If it sees that you're doing something that doesn't look right, if you type in something that you think is correctly in terms of the command line, MATLAB can quickly point out some possible problems, right? It can also make suggestions. It can give you warnings. And so that's something you don't have, obviously, if you go outside an editor in MATLAB. If you go outside and create just a text file, then you're on your own, because the program you may be using to write a text file doesn't know you're using commands related to MATLAB. So keep that in mind. If maybe as an emergency, it's a good thing to know that you can do it, right? Or maybe as a first draft, and then just especially if you have a large function that you need to write, and you don't want to be in MATLAB all the time, or you cannot be in MATLAB all the time. You can write it outside, as close as possible as it's got to be, and then import it into the MATLAB editor, and then the MATLAB editor will quickly tell you if something doesn't look right. Okay. All right. So in any case, that's you go into the editor tab and write the functions, and you're going to save them as .m files. So in this case, we have the two functions that we wanted to define, right? We have the RD function and the VR function. Both of them take one variable input, so X is the input, and give you one output, okay? And in both cases, you can see how the output is defined, right? Based on, if you go radians to degrees, the output will be defined given this expression when you give it X, all right? For degree to radians, again, we're going to use this expression with the output going to this output variable. By the way, these bars here are not part of the commands. They got stuck somewhere for some reason. When I was doing this in MATLAB, it's just the cursor indicator. So ignore those bars here, right? They're not part of any of the commands by any means. But you can see how the functions is defined, right? In this case, it's just very simple, right? But again, imagine that if we didn't have something like that, then every time we need to convert from radians to degrees, for example, we have to write this, right? So it's a lot simpler just to say RD or DR and give it the argument. So this is how you will define it, and that's how you will save it. And notice here that we have comments, right? And the comments are critical, especially at this point, and we'll see that in a few minutes. All right, so the next thing right? We wrote our functions in MATLAB, is to test the solution. And we're going to compare this to the hand solution. So to test it, we can use a script, or you can do it in the MATLAB command if you want. So let's say you wrote a script just to test it like this, right? So we're going to define a vector of degree values. In this case, we're going to go from 0 to 180 in steps of 15. And then we're going to call the dr function and use it to find the degrees in radians, right? And so this this line here will place the output of function dr in a variable called radians for all of the values defined by degrees. And then we're just going to create a table to use it in the output, right? Degrees, underscore radians, and we're going to create a table for the degrees in the radians. And then we're going to define another vector so we can test the R to D function. And in this case, we're going to create a set of numbers from 0 to pi in steps of pi over 12. And then we're going to pass that variable as radians to the degree function and get the degree information. And then again, create another table that's going to show us the result. And what you see is when you run this, you'll see this as the output, right? So for every value of degrees here, dr converted it to radians, as you can see here, right? So, and it shows you here the degrees and the radians, degrees and the radians. And at the same time, when we did the second half of this script, for any value of radians, the function rd gives us the degrees, right? Now, remember, this here is not part per se of the user-defined function. The user-defined function is just this part, dr, degrees, rd, radian, which we have already defined here, right? This is just a script using those two functions, okay? So the script could be anything. In this case, again, we just wanted to create two tables like that. And we use a script to do it based on the functions dr and rd that we define, okay? Okay, so an important thing that I said before, be careful with the first comment that you have in the function. The first comment line in the function file is referred to as the h1 line, okay? That h1 line, just make sure that the line has important keywords that will describe that function as accurately as possible. Because when a user types, for example, look for dr in the command line, MATLAB will search for that specific dr keyword, and it's going to look at the h1 lines of all the functions that it knows, and if a match is found, the name of that function file and the h1 line that contains the match is going to be displayed, okay? So it's a good thing for you to find the information related to the function you're using. So that's a critical part of writing the function, the comment line, believe it or not. So the line is displayed also when you type help in the function name in the command line. And this is true for MATLAB built-in functions, right? You've done that before when you want to find out what a function does. So it also applies to user-defined functions. For example, if we type help dr in the command line window, we're going to get this information, right? Because now MATLAB can find it, as long as it can find it, obviously, because it's got to be in a place where it can find this function. As long as it can find the function, it's going to go into the function and read this line, right? See? And that's what you see. And that's what it displays as a help. So it's not really something that's going to stop you from writing a function or for properly coding a function, but but it's really a very important part of writing a function, because if you later need it or need a description of it, that information is going to be really, really helpful. Okay. Now, we can also obviously have functions that have multiple inputs and outputs, right? The ones we looked at here only have one input, one output, one input, one output. But obviously, you know, the cases where you're going to have more than one of each. So if that's the case, then the formatting is that you're going to use is, you know, again, you're going to have your function name on the right, the keyword function preceding your output, right? So the function name followed by the variables you're going to use as inputs, right? In this case, if you have more than one, then they're going to be obviously enclosed in parentheses and just separated by commas. As many variables as you have. So this will be your input parameter section. And for the output parameters, basically the same thing, except that you're going to have, you know, the outputs obviously separated by commas, like this one, and your output parameters, you know, followed by the list of your output parameters, followed by the function. Okay. Now, remember we said at the beginning that parentheses are needed even if the function has no input parameters. So if a function happens to not have any input parameters, you still need to have the parentheses in it, and it's just going to be empty parentheses. If there's no output parameters at all, just in case that we don't have any output parameters, then that's a special type of function, and it's called a void function. So a void function will not have any output parameters. Okay, that's just special case. And so remember, when you display or describe or define your output parameters, you have to use brackets to enclose them. But the input parameters, you use parentheses. Okay. Now, if we use this as an example for showing multiple parameters, we have this function that will calculate the distance, velocity, and acceleration of a particular car for a given value time, assuming all three parameters are initially 0. So the function name is motion, and you pass or you give it time, and it'll calculate the distance, the velocity, and the acceleration. And of course, you have already defined these equations and tested those equations to understand that that works, right? Again, ignore this bar here as part of the mouse when I was typing this little function. So again, the bar is not part of the function. But anyhow, you get the you know, the idea behind this function, right? Motion, you pass it time, and based on these equations, it generates a acceleration, the velocity, and distance. Okay. So when we use that function, obviously, you know, if you say, you know, you're gonna give it this, right? The distance, the velocity, it's gonna put into the output rather into distance, velocity, and acceleration variables. And if you say motion 10, it's gonna give you these expressions here, this answers here. Okay. If you don't give it, if you call the function without specifying the outputs, right? In this case, we specify the outputs that we want. But if you don't specify the output, only the first output will be returned. This one here. It only understands that you want the first one, not the other ones. If you want all of them, like in this function, as defined, you have to tell it, you know, that you want the 3 outputs in this case. And also notice that if we type help motion on the command line, it'll give us a description of what the motion function does based on this comments here. Now, remember, just to make sure, you're only going to see that information for the first set of comments that you have. Any other comments you have after that, then you should have comments, but they're not going to show up under help. Okay? This is just for that H1 line that we were describing previously. Okay. Now, before we go into the next example, I want you to remember that in MATLAB, all variables are matrices, are treated as matrices. So for example, if you define a variable A equals 2, it creates a 1-by-1 matrix. If you want to check it, create a variable like this, A equals 2, and any scalar, it really becomes a matrix. If you look under the workspace, if you double click on that variable under the workspace, it'll show up as a 1-by-1 matrix. So it's important in the previous example, for us to use this dot operator, right? Which specifies the element by element multiplication. All right. So that's just a reminder of why this dot is there, that period is there. If we use that function again in a little different way, if we remember the previous example, we just gave it a single value of 10, right, as the time, and the function itself then gives us the distance, velocity, and acceleration. We can also define a vector of times if we want it, like if you want a whole set of results for different values of time, then we can define that vector, right? In this case, right, we define the time from 0 to 30 in steps of 10, and we pass that vector to the function. The function will again compute the distance, the velocity, and the acceleration for each of those times as specified. And in that example, if you wanted then to, and this is not part of the function, but just to show you that if you wanted to organize the results in the table format, you can use this this statement here. And it's just using the transpose operator to convert the rows into columns. Okay, so this is what we got before, right? By running it, right, directly. And if we, and of course the information is already in these variables, distance, velocity, and acceleration, and is in this time vector that we created. So all we're doing here is taking those 4 variables and put them in a matrix called results, or variable called results, and just taking each of those rows into columns, right? So as you can see here, this row becomes this column, this row becomes this column, and so forth. Again, this has nothing to do with the actual function, but it shows you, a way of organizing the results and keeping it, better looking. All right. We mentioned again that there are cases where you have functions with no input and no output. Well, there are cases, for example, when you type, even in MATLAB for some of the built-in functions, is that if you type date, there's no input variable, or there's no input requirements for date, but the answer, will be given. It'll give you the today's date. If you type pi, for example, you get the value of pi and so forth. So those are examples of cases where you don't require an input. For example, let's say, let's look at a function star here, where that function doesn't require any inputs and doesn't require any outputs, right? This is an example of a void function, okay? Has no inputs and also has no outputs. And is defined like this, right? It doesn't really matter how, how it's defined. So I'm going to show you an example of an input and no input, no output example. But what it creates is this, right? So just by typing the name of the function, in this case, it's just star, and we type it again with no arguments, you create this graph. So there are no values returned, but it creates a figure that shows a star in polar coordinates. So this user-defined function requires no input and produces no output, but still draws a star in polar coordinates. Okay? So the next thing we're going to look at is, and this is very easy, how easy it is to determine the number of inputs and the number of outputs in a arguments in a function. There will be times when you want to know the number of input arguments or the number of values associated with an output, the output of a function. And there's two MATLAB built-in functions that you can use for that purpose. One is the NARGen function that determines the number of input arguments in either a user-defined function or a built-in function. And the other one is the NARGout function. Again, very similar to the NARGin function, but it gives you the number of outputs from the function. Sometimes that's useful to know, right? For example, if you type Nargin sign, and by the way you use the function is that you type in Nargin, and you're going to use parentheses, and in parentheses you're going to put the name of the function you're investigating in terms of how many arguments it's going to take. But it's got to be in single quotes. Okay. So in this case, we type in single quotes SIN, and it tells you that the number of input arguments that it takes is 1. We can do the same thing for the build, for the function we built for DR, and we know that the function expects 1 input, right? Same idea for the NARGout command, which will tell you the number of output variables that you're going to get. And in the case of a SIN, sign function, you know you're going to get 1 result. And same thing for the DR function, we get 1 result, right? 1 output out. An example of a function that has multiple outputs is, for example, the max function in built-in function in MATLAB. If you type or if you use NARGout and max in single quotes, then it returns the number of outputs that the function is going to return. Okay, so we have a few other things I want to talk about functions, but I think I want to do that in the next lecture. And so let me know if you have any questions or any comments, and I'll be happy to answer them. And I'll see you in the next lecture.